Welcome to my Math 1111 lecture video on quadratic equations and inequalities. I hope you'll find that a lot of this material is review, especially if you took Math 98. If you did not take Math 98, you may struggle quite a bit with this, not to scare you off, but if you need some more detail, let me go ahead and refer you to my website that contains videos for Math 98 topics. Go to www.gpc.edu/tilde A Hendrick/math0098/98 video clips.htm. And if you look at Chapter 11 videos, you'll find these concepts here that are supposed to be reviewed covered in a lot more detail. Okay, so what I want you to do is to review the methods to solve quadratic equations, understand the discriminant and how it determines the types of solutions, and solve quadratic inequalities. We are going to take a look at doing this just analytically in this video, but I am going to create the graphing calculator video and show you how you can look at it from a graphical perspective. So the methods to solve quadratic equations that you should be familiar with are to solve by factoring. And that's really the property of zero products you might see. That is, if you have one side of an equation expressed as a product set equal to 0, that means that either A has to be 0 or B has to be 0. Right, because the only way two things multiply to be 0 is if one of them is 0. So the goal here is that you will factor, well, first set one side equal to 0, factor, and then set each factor equal to 0. Solve by the square root property. That really is only set up for a special type of equation, one that looks of the form x squared equals some number k. And if that is the case, then x has to be either positive the square root of k or the negative square root of k. Solve by the quadratic formula. This is the biggie. To solve a quadratic equation that's of the form ax squared plus bx plus c equals 0, the quadratic formula states that our solutions are the values of x which are equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. That's actually derived from completing the square. We talked a little bit about completing the square in the last video, but completing the square is what allows us to really put this standard form into a squared form, kind of like that vertex form we were talking about, and then use the square root property to solve those equations. You don't have to know how to do all that, but just to know there is really a rhyme or reason to where this came from. It's not just pulled out of the air. So the key, though, to use a quadratic formula is that the equation has to be equal to 0, and then you identify the values of a, b, and c and plug into that formula. So let's take a look at how we can solve some equations. I'm going to do some in more than one method just so you can see you'll get the same result regardless of the method that you use. Some equations you can only use one method, so we'll talk about that too. So if we wanted to solve x squared minus x minus 6 is equal to 0 by factoring, and then we'll also do it by the quadratic formula. Well, to solve it by factoring, I already have one side equal to 0, so that's good. What I have to do then is examine the trinomial x squared minus x minus 6, and that does factor. We factor it by looking at the factors of 6, whose difference is 1, and those are 3 and 2. Since the last sign is a difference, we know that the signs in the binomials are different, with the larger one being negative. So we have x minus 3 times x plus 2 equals 0. Therefore, we can set each factor equal to 0 and find that our two solutions are positive 3 and negative 2. You could check, right, if I plug in the 3 squared is 9, minus 3 is 6, minus 6 is 0, so that checks. Same thing with hold true for negative 2. One other thing, that the degree of the equation will always determine the number of solutions that you have. So the solution set would consist of the numbers -2 and 3. Now let's just say I wanted to do quadratic formula. Maybe you don't like factoring. The quadratic formula, we have to identify the values of A, which is 1, right? B is -1, and C is -6. So then we plug into x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we would have to do the opposite of -1 plus or minus the square root of -1 squared minus 4 times, what is a? Yes, a is 1. And what about c? It is -6, correct. And that is all over 2 times what? Yep, a is 1. That's correct. So now you just get this ugly expression. You've got to simplify it, but we can simplify it to be this. The opposite of -1 is 1, plus or minus the square root of -1 squared is +1. -4 times 1 times -6 would be a plus 24, and that is all over 2. So almost done. We get 1 plus or minus the square root of 25, right? Remember to add inside the radical before you apply it, over 2. So we get 1 plus or minus 5 over 2. And you might say, well, that's not -2 and 3, but it is, right? This means 1 plus 5 over 2, or 1 minus 5 over 2. 1 plus 5 is 6 over 2, which is 3. 1 minus 5 is -4 over 2, which is -2. So it doesn't matter the method, you will get the same result in the end. Now obviously, if something factors and you see that, that's the quickest solution. Quadratic formula gets you there, you just have to go through that tediousness of the formula. Now what about x plus 2 squared equals 49? How can we do that? Well, the square root property, if you recall, was of the form if x squared is equal to some number k, then x is equal to plus the square root of k or minus the square root of k. Sometimes we write it like this, plus or minus the square root of k. Keep in mind that we're trying to undo the operation attached to the x, so to undo squaring is the square root. And there are two numbers whose square is the same result, so we have to keep in mind that plus or minus. Now, x doesn't have to just be a single variable, it can be any quantity. So if I want to remove the square on this x plus 2, I would have to do it as this way. X plus 2 is equal to plus or minus the square root of 49. So therefore we get x plus 2 is equal to plus or minus 7, right? Square root of 49 is 7. Now we can subtract the 2, so we get -2 plus or minus 7. Are you with me on that? Okay, now here again we have that plus or minus to contend with, so we know that x is -2 plus 7 or x is -2 minus 7. So our two solutions are 5 or what? Yep, -9. Now you might say, well, how can I use the quadratic formula if I wanted to solve that problem? Well, you could. It's kind of going around your elbow to get to your thumb, so to speak. That is the very long way around, but I could do that if I wanted to, so let me kind of show you over here. If I wanted to use a quadratic formula, it has to be in that ax squared plus bx plus c equals 0 form. So I'd have to undo everything in this problem. Do you remember to square x plus 2? You would have to do x squared plus 4x plus 4 equals 49. Then you'd say x squared plus 4x minus 45 is equal to 0. Is that right? And then you have to say A is 1, B is 4, and C is negative 45. Put into that formula, work it out, and you should get 5 and negative 9. Okay, so there is a way to apply the quadratic formula to actually every single equation. It just may not be the most efficient use of your time. Now what if I have 5x minus 3 squared is equal to negative 16? This is set up to use the square root property, right, because I have a quantity squared equals negative 16. So if I wanted to use the quadratic formula, square root property on this, I'm going to undo my squaring, so I'd get 5x minus 3 is equal to plus or minus the square root of negative 16. Now I'm asking you to pull back in your brain, see if you can uncover the cobwebs and bring out complex numbers. Do you remember that? That the square root of negative 1 is I. So if I have the square root of negative 16, that is really 4I. You remember that? Right, because the square root of a negative number is not real, so we have to use this imaginary number to represent the square root of negative 1. Now we need to add 3 to both sides, so we would add it in this way. We would say 5x is equal to 3 plus or minus 4I. And now we can divide by 5 to get 3/5 plus or minus 4/5 I. So there are two solutions. They are complex or imaginary, but the solutions are, excuse me, I don't need that parentheses there. So solutions are 3/5 plus 4/5 I and 3/5 minus 4/5 I. So just to keep this terminology in mind, that we have two complex solutions or two imaginary solutions. Wanted to solve just a few more equations just to make sure you're comfortable with that, and certainly on the homework video I'll show you even more examples. If I want to solve x squared minus 5x equals x minus 7, you'll notice I didn't tell you which method to use, so we need to kind of talk through how do you know which method can be used on these types of problems. It is quadratic, so the first thing that I would tell you to do is put it in the form of ax squared plus bx plus c is equal to 0. So if we set one side to 0, we would have to do this. X squared, subtract x from both sides to give us negative 6x. And then we can add 7 plus 7 is equal to 0. You might think, oh, it factors. Does it? No, because here I'm looking at what factors of 7 would have a sum of 6. And there aren't any, right? The only factors of 7 are 1 and 7, and their sum is 8. If this happened to have been a minus sign here, then there are factors of 7 whose difference is 6. But it doesn't factor in this form. So if it doesn't factor, we would want to use the quadratic formula. So I'm just going to write out some steps here. So we would do this. Write it in standard form. Check to see if it factors. If it does, like I said before, factoring is sometimes the easiest way to go about it. If it doesn't factor, then just use the quadratic formula. So if we use a quadratic formula, a is going to be 1, right? B is 6. Nope, you caught me right. 6 is not right. It is negative 6. And C is 7. So you're going to be saying the quadratic formula in your sleep, at least I hope. You're going to say, or having nightmares, right? You would have nightmares if I sung you the quadratic formula song, so no. Have you heard that song? You do negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. I used to could carry a tune in a bucket, but now I can't. Sorry. So you would have the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times c, which is 7. And that's all over 2 times 1. So we would get 6 plus or minus the square root of 36, right? When you square a negative, you get a positive, minus 4 times 1 times 7 is 28, and that's all over 2. Oops. So here we go. Just simplifying now, we get x is equal to 6 plus or minus the square root of, what is 36 minus 28? Right, is 8. Oh, now the tricky part. Very, very tempting to want to say 2 goes into 6 3 times and write this as 3 plus or minus the square root of 8. I cannot do that because it's a sum in the numerator, so if I do the division into the 6, I also have to do it into the square root of 8. So as a rule of thumb here, what you need to do is simplify the radical first. If you recall, the square root of 8 is really the square root of 4 times 2, which simplifies to be 2 on the square root of 2. Okay, now we can divide the 2 into each component. So we would get x is equal to 6 over 2 plus or minus 2 on the square root of 2 over 2, which reduces to 3 plus or minus the square root of 2. So your two solutions are 3 plus the square root of 2 and 3 minus the square root of 2. And you can use your calculator. I'm sorry, I didn't mean to put parentheses there. Need to put brackets. You can use your calculator to approximate those if you like. Let me type that in real quick on my calculator. 3 plus the square root of 2 is 4.4, and 3 minus the square root of 2, 1.6 if I round to one decimal place. Okay. Now, these are called irrational solutions. Okay, they're real numbers, right? I don't have any imaginary part, but they are irrational solutions. Real but irrational. And that brings me to, yes, my next topic, the discriminant. What is the discriminant? The discriminant is actually that expression b squared minus 4ac. If you recall the quadratic formula. The discriminant is that number that's inside the radical. So that tells us the types of solutions we're going to actually get. If the discriminant is positive, the square root of a positive number is a real number. So there's going to be 2 real solutions to the quadratic equation. Now, if the discriminant is negative, like we saw just a moment ago, the square root of a negative number is an imaginary number. So there will be 2 imaginary solutions. And what happens if it is 0? Well, what's the square root of 0? And the square root of 0 is just 0, so we're really not adding or subtracting anything, so we just get this negative b over 2a. So in that case, there's only one real solution. Now we can back up for just a moment and let me show you something here. Remember the very first equation I worked? We could solve it by factoring. I also solved it by the quadratic formula. What was the discriminant when I used the quadratic formula? Yeah, it was 25. What type of number is 25? It's positive, but what else is it? Yeah, it is a perfect square. So if you have a positive number that is a perfect square, that tells you 2 things. tells you that the equation is actually factorable. That's really just a bonus part. But it also tells you that the solutions are going to be two rational solutions. Rational meaning integers or fractions where the numerator and denominator are both integers, like 3/5, 1/3, -7. Those are all rational. If you recall the problem that I did here, my discriminant was 8. 8 is positive, so I knew I had two real solutions, but these were irrational. Irrational means that they have a decimal form that continues forever in a non-repetitive manner. And so if you have a number that is positive but not a perfect square, then that tells you that you're going to have two irrational solutions. Okay, they're still real, but they're just irrational. So here's an example. Let's find the discriminant of this equation, 4x squared equals 6x plus 3, and determine the number of real solutions that we might have. Well, to determine the discriminant, it has to be in that form ax squared plus bx plus c equals 0. And then we have to find the value of b squared minus 4ac. I mean, technically you could solve the equation from start to end and figure it out that way, but this would be a quicker way to do it. So I'd have to put it in the form 4x squared minus 6x minus 3 is equal to 0. So my value of a is 4, right? B is -6. C is -3. Very good. So when I plug into b squared minus 4ac, what would I get? Right, b is -6 squared minus 4 times the value of a is 4, and c is -3. So just simplifying this now, we get 36. Notice a negative times negative is positive. What is that? 16 times 3 is 48. And so this number is 84. So what does that tell you about the types of solutions you would expect? All right, so look at the sign. The sign of the number is positive. Yep, so that tells me that there are two real solutions. Now, real solutions have the two categories, rational and irrational. So which one would it be? The way you know that is 84 a perfect square? No, 81 is a perfect square, right? No, it's 9 squared. 10 squared is 100, so 84 is not a perfect square. So that tells me that those solutions are going to be irrational. Now, the last objective, hopefully we can get through this in a reasonable amount of time, is solving quadratic inequalities. And this was covered in Math 98 if you had that as well. To solve quadratic inequalities, what we need to do is first find where the expression is equal to 0 or equal to whatever number. And then every other value of x is going to be where it is not equal. So that is where it's either greater or less than that expression. And so we're going to form a region of numbers that we can test to see if they make it true or false. So the way that we do quadratic inequalities is the very first step is we set x squared plus 6x plus 8 equal to 0. That is, the first thing is replace the inequality with an equal sign. So we solve the associated equation. Now you're going to use one of the methods that we just talked about to solve it. Here, this one does factor, right? The factors of 8, whose sum is 6, would be 4 and 2. All signs are positive. So we get that either x plus 4 is equal to 0, or x plus 2 is equal to 0. So x is equal to -4 or -2. So that's step one. So if we look at the number line to represent all the values of x, we know that at -4 and at -2 are the only two numbers in the whole world that make x squared plus 6x plus 8 equal to 0. Every other value that I plug in for x is going to make this expression either less than 0 or greater than 0. And I've got to test to determine where those solutions lie. In other words, I need to find all the values for x that make this quantity, x squared plus 6x plus 8, less than 0. Well, it's a wonderful thing, and I'll show you more with this on the graph and calculator. But I only have to test one number in a region. Like once I find where it's equal to 0, every number in these regions that are formed are going to test in the same way. That is, all the numbers from region A would make this expression negative, or all of them would make it positive. I'm not going to have it going back and forth between the two. Same thing in region B. All of the numbers in region B would make that expression either positive or negative. It will not make it go back and forth. And the same thing in region C. So what I do in step 2, I put the numbers on the number line. So we're going to place the solutions on the number line. And then what we're going to do is test a point from each region. So in step 3, oops, I have another equation there. Let me come over here for a minute. In step 3, we're going to test a point from each region. So that is, in region A, B, and C, we're going to plug in a value into the original inequality. So test points in the original problem. So what's a number in region A? Number in region A is everything to the left of -4. So like -5, -6, -10. Doesn't really matter what number you use. So let's just use -5. So I'd have to say is -5 squared plus 6 times -5 plus 8, is that less than 0? So what is that? 25 minus 30 is -5 plus 8 is 3. Is 3 less than 0? No. What about region B, between -4 and -2? Yeah, like -3 is the only integer value there. If you had two consecutive integers, like if that was a -2 and that was -3, you'd have to use like -2.5 or some decimal form. If x is equal to -3, when we plug in, we get -3 squared plus 6 times -3 plus 8. Is that less than 0? See, that's 9. Minus 18 is -9, plus 8 is -1, and -1 is less than 0. So region B so far checks. Then a number out of region C is anything to the right of -2, like -1 or 0. I really like to test 0 if it's in my region. We plug in 0, I would get 0 squared plus 6 times 0 plus 8. Is that less than 0? 0 plus 0 is 0, plus 8 is 8, which is not less than 0. So what I have discovered now is that the only region that tests true is region B. So that means that my solutions to this problem lie only in region B. Now I need to know what happens at the end point. Can I include those in my solution or not? Well, if you notice that my inequality was strictly less than 0, my solutions of -4 and -2 came from where it was equal to 0. So if something is less than 0, it is not equal to 0, which means I cannot include these. So I indicate that with the use of parentheses. So my final step is to write the solution set in interval notation. So the interval of numbers that satisfy this problem are from -4 to -2. Now let's look at x squared plus 5x is greater than or equal to 2. So if we wanted to solve this equation, we would say x squared plus 5x is equal to 2. So x squared plus 5x minus 2 is equal to 0. Now we probably need to use a quadratic formula, so we get a is 1, b is 5, and c is negative 2. So x would be equal to the opposite of b, so the opposite of 5, plus or minus the square root of 5 squared, minus 4 times a times c. And that's all over 2 times a, which is 1. So here we find we get negative 5 plus or minus the square root of 25 plus 8 over 2, which is negative 5 plus or minus the square root of 33 over 2. So step 2 is to place these numbers on the number line. Well, negative 5 plus the square root of 33 is larger than negative 5 minus the square root of 33, so at least I know negative 5 minus the square root of 33 over 2 comes here, and negative 5 plus the square root of 33 over 2 is here. So on the calculator, I can evaluate those expressions because I need to know what that represents so that I can test points, right? So we have negative 5 plus the square root of 33, and then divided by 2, so this value is 0.37, and then negative 5 minus the square root of 33, and then divided by 2 is negative 5.4, roughly, okay, approximating. So I need to test a value out of regions A, B, and C. So I need to find a number less than negative 5.4, so if you want to use like negative 7, right? So I'm testing in my original problem, is negative 7 squared plus 5 times negative 7, is that larger than or equal to 2? So what is that, 49 minus 35? Yes, that's 14, which is greater than or equal to 2, so that checks, right? What's the number out of region B? Between negative 5.4 and 0.37, 0, my favorite number, right? Especially for this. Is 0 squared plus 5 times 0 greater than or equal to 2? Nope, that's 0, which is not greater than or equal to 2. Are you noticing a pattern? False, true, false, true, false, true, right? Alternating. C, region C, a number larger than 0.37, so if you want to say 2. So is 2 squared plus 5 times 2 greater than 2? Yeah, that's 4 plus 10 or 14, which is greater than or equal to 2. So my solutions lie in region C and in region A. Can I include the endpoints? Yes, because I'm allowed to equal to, and that's exactly where those solutions came from, so I use a bracket to indicate that. So in interval notation, I would have negative infinity to negative 5 minus the square root of 33 over 2 with a bracket, union bracket, negative 5 plus the square root of 33 over 2 to infinity. And my last problem, sorry, this has been a long video, I know. X squared minus x plus 1 is less than 0. So I first start by solving the associated equation, x squared minus x plus 1 is equal to 0. So a is negative 1. No, it's not. You're thinking, what are you thinking? A is 1, b is negative 1, and c is 1. So when we plug into the quadratic formula, we would have the opposite of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 1 all over 2 times 1. So the opposite of negative 1 is 1. Negative 1 squared is 1 minus 4 over 2. So that is 1 plus or minus the square root of negative 3 over 2. But what is that? Yeah, the square root of negative 3 is really I on the square root of 3 over 2. What types of numbers are those? Imaginary. The most important point is that they are not real. So whenever we go to the number line and try to place those numbers on the number line, they are not there, right? The number line is just real numbers. So what that means is that the number line is either all containing the solutions or doesn't contain any solutions. So what we would do in this case is only test one number. And what is my favorite number to test? 0. You got it. So if we plug in 0, 0 squared minus 0 plus 1, is that less than 0? No, because that's 1, which is not less than 0. So since the only region that we had to test tested false, that means that there is no solution to this problem. So the empty set is the solution. Now, notice if this symbol had been greater than 0 in my original inequality, 1 would be greater than 0, right? So that would make it all true, which would be negative infinity to infinity. So just because we don't have any real solutions to the equation doesn't mean that there's not going to be a solution to the inequality. You have to go through this last step and actually test. Okay, I think that is it for this section. Make sure you refer to my calculator video because it's going to have a lot of skills that you can use to show how you can work the graph and the solution together. Okay, have a great day.